I'm Chrissy Donaldson. I'm going to take it back a bit because I know some of you here are at sixth form doing A-levels. So I myself did AS levels in further maths and psychology. I went on to do A-levels in maths, business and ICT. The reason I chose those subjects was because I thought I was good at them, I thought I could do well, and I thought they could be applied to a large, pretty much any job, business, ICT, maths, come in useful. I also had a really good maths teacher at school, which, if you take a minute to think, I think most of us here are good at maths, and I think most of us here could picture someone that taught us at school that really had an impact on us and made us passionate about maths. So after I did my A-levels, I went on to study maths and statistics at Plymouth University. The reason I chose to do maths and statistics was because, again, I thought it would lead to a better careers, which it does. Again, I thought it would be interesting, and more importantly, I thought it would challenge me. I think generally maths is challenging, which is why I think a lot of mathematicians like it. They like the challenge. So after I graduated, I came into Sparx, the company I work for, as a content scientist. So that was 2.5 years ago. I've been there 2.5 years now, and I'm going to talk about what I currently do at Sparx and what Sparx as a company does. Okay, so what is Sparx? Sparx is an education research company. There aren't very many of these in the world. It's quite a small area, it's quite niche. It was set up in 2011, so it's quite a recent company. I'm not quite sure we're a startup anymore because we are growing very rapidly, but it's definitely new and exciting and a great company to work for. The research area of this is very important. What we're doing is basically a massive scientific experiment. So it's all about finding evidence for and against theories that we create. And because we are daily involved in a classroom, we can find evidence. So we use technology daily in a classroom, and obviously the students using that technology generate lots and lots of data. And the best thing is we're based in Exeter, of course. So we talk to teachers as well on a daily basis. We get feedback from students, and being in school is a very invaluable thing to drive our development. So a content scientist, it isn't a job that is anywhere else in the world. It's a job that we've came up with to suit our needs as a business. And it's a very exciting job, and as part of my job, I devise content to go into our technologies. So here's an example. I'm going to do something a bit different because you've listened to a lot of talking. And I'm going to get you for 2 minutes to just talk to the person next to you and think about this problem, think how you would solve it, and more importantly, how you think you would teach that problem to a Year 7 student and 11-year-old. So I'm going to ask in a couple of minutes for some hands up and some ideas, but off you go for 2 minutes. Thank you. Okay, thank you. That wasn't quite 2 minutes, I did slide slightly. But could I have some hands up as to some ideas of, one, how you would solve it, and two, how you would explain it? Or I'm going to start picking on people. Someone? Yeah, you at the back.
Okay, so we'd explain to the students first, you cannot just rapidly start adding one to performance, like you've got to explain the basic ground rules, so explain basically what you can't do to start with.
Yeah.
Then we'll explain that you've got to have the same factor on the bottom. In order to get that, we're going to take the simple approach of multiplying the 6 and the 9 together, and multiplying the left-hand side of it by 9 on top of the bottom, and the right-hand side by 6 on top of the bottom.
Yeah.
So that gives us 2 factors over 4.
Yeah.
And then you can then add the numbers in the top. And if we were more advanced students, maybe we would then explain to them about how to factorize and stuff like that.
That's great, thank you. Yeah, so I'm sure a lot of other people had different approaches to this. For example, if you were with a very low ability student, they might not be able to multiply 6 by 9. So you might then think, well, what about 3, and go from there. So there's lots of different ways you can do it. And I think this has highlighted that it is a challenge. It really depends where this question sits within a lesson. Do they know their timetables? What did they do last lesson? So it's very, very tricky, actually, to design a good lesson, to write a good question that lots of different people can attempt. So one of the things that we do to decide which is the best way to teach a particular problem is by looking at our data. So our data is generated by students. It's always growing because we are in school on a daily basis. It's very big. We have millions and millions of data points. It's very layered, so you could look at it from a student's perspective, or a class, or a school, or a region, or a country. Or you can look at it the other way in terms of a question, so like the one we just saw, or a topic, fractions, or key stage 3. There's so many different angles you can take on this data, and every angle you take leads to different conclusions, different theories. So future trends, I'm just got a minute left. So what we're doing at Sparx is the fusion of education, technology and statistics, which, like I said right at the start, is very rare. I think education and technology together is becoming more of a common thing, things like interactive whiteboards in classrooms, but actually fusing in that statistics aspect of it as well, having real-time analytics in the classroom, is something that's brand new. And teacher acceptance is the next point, so we need to empower teachers to be confident with the tech, which they are becoming, and then eventually confident with the statistics aspect of it as well. We can give them data and feedback, but what do they do with it? Is it actionable? And finally, even more data. So as there's more and more companies doing this, more and more technology, the database is growing, and there's a lot of sharing of data as well throughout companies. And that 10 seconds. 10 seconds. And that means that we can formalise what we're doing, formalise our research. So finally, here's our website, and we're always recruiting for talented maths and stats undergraduates, and there are a couple of our current